check. Okay, yeah, the audio's working. Hoorah.
Test my audio on this side. Testing. Okay, I think we're good as well, Hudson, on this side.
Great. Hi, everybody. Welcome. I'm going to pull up the agenda, but we were just talking about EWASM, and basically, what was the question someone had? Like, should we implement it before sharding and all that stuff?
Yeah, like, should EWASM be available in mainnet somehow?
So, is anyone from EWASM here to, like, kind of give an opinion?
I could, if you can hear me.
Yeah, what's up?
It's Alex, or Exic. Yeah, just to reflect to the questions from Peter, we are working on a testnet, a pure EWASM testnet, and Peter mentioned a multi-client support in that. So for that, we have CPP Ethereum is our main client at the moment, but there is work going on to support Go Ethereum, which I think is it's close to completion at this point. So the testnet hopefully going to run both CPP Ethereum and Go Ethereum. And then as regard to whether it could be introduced on the mainnet, for that we have a proposal in progress which would offer a subset of EWASM to be considered for the mainnet, and that subset could be used to write precompiles, things which are written as precompiles today, to write them as a WASM contract, but it would still, because it's a subset, it would still require consensus to decide whether we take them onto the network or not. So that could be like an intermediate step.
That's really interesting. And I guess what we could even achieve kind of gains in simplicity, because we could like basically force all the existing precompiles to be rewritten as specific pieces of WASM code.
Yeah, correct. We actually have those rewritten. The benefit of this from the WASM side would be that it's a restricted set, so we may not need to address some of the concerns which have risen around WASM, and we could still research them, because these set of precompiles which would be compiled to WASM would have to be reviewed by all the client developers. There need to be consensus around them. There is no risk of a random contract being deployed.
Yeah.
Tentatively,
I like this.
Cool, because then we get new precompiles, but we don't actually have to do any consensus testing on them. We only have to do verification that they do what they're supposed to do, but no consensus.
Oh, yay. No, like, this is nice, because then we can make Zuko happy about Blake 2. We can make the L events Hassan and Co. happy by adding finite field operations, so you can do start verification and a bunch of things.
And all the DNS precompiles.
Yep. Wait, ENS precompiles?
The ones that are being pushed because of ENS.
Oh, which ones are those again? Oh, you mean like the weird hash functions and signature schemes that people want to throw in because like the traditional DNS system uses them. Yeah.
Yeah.
There's one other one that people, Curve 25519, I think people wanted. Yeah.
Okay.
One last comment on that. So this proposal is currently being worked on because there are a couple of different options to be explored. And one of the options is whether it should have its own metering rules. And if it does, then it would have to be only written in WASM because it's specific to WASM. But if we decide to have this random metering logic we have followed so far for precompiles, then it would be possible for clients to decide whether they want to use the single written code in WASM, or they could just keep writing their own version of precompiles. But we haven't reached a decision on which one makes more sense, and wanted to get a bit more detail on these before we propose this to this call. But I think we really hope to have like a proper proposal for the 2 calls from now to be discussed.
Cool. That sounds good. If anyone on YouTube's hearing an echo, it's because I'm in a really weird conference room where I'm not familiar with the settings, so sorry in advance. I'm just going to try to mute when we're not talking. Cool. So I guess what came from that is, you said in 2 more meetings from now, Axic, you're going to have something?
Yeah, we already have an issue on the WASM design repo to discuss this, and everybody's welcome to check it out. And yeah, I mean, personally, I would be happy to discuss this even on the next call or the call after. But we wanted to get some more detail from our side before we propose it. But yeah, I don't mind whether we keep discussing it on the next call.
Okay, sweet. Let's get to the agenda unless anyone had anything else with that. Cool. First off, is Dimitri here for testing? Okay, we'll skip testing for now then. Let's just run through client updates real quick. Geth?
We don't really have any spectacular updates. So we did a release last week during the 2 meetup. It's mostly network polishers, light client polishers. We're trying to figure out a way for light clients to be able to sync to the chain faster, etc. So we're mostly hacking on light client stuff and discovery stuff, but no particular progress to report.
Cool. Parity?
Okay. Yeah, can you hear me?
Yep.
Same story. We are planning a major release very soon, but there's not much to announce right now.
Okay, sounds good. Harmony?
We have finished some current activities this week and starting to work on Beacon Chain since Monday. So yeah, that's it. Pretty excited about ongoing sharding, upcoming sharding research work. Yeah, that's it.
Cool. Trinity?
We are working away at our kind of next major release. We've got some architecture that we're working on for plugins to be able to host kind of third-party functionality that kind of excited about, but in the very early stages. But generally working on syncing logic and sort of still a lot of the core functionality.
Cool. C++ Ethereum? Paul, do you have a CPP Ethereum update? Or I think you're muted if you're trying to talk. Okay, we can skip for now. Pegasus, what's up with you guys?
Hi, Hudson. Shahan here. I'm here with Ben, who you all know, and Matt Halpern, one of the core devs working on Pantheon. Thanks for allowing us to talk about Pantheon today. I'm very excited to announce that Pegasus is planning on releasing our mainnet-compatible Ethereum client, Pantheon, at DEF CON 4. So some of the details around it are that the client will meet the requirements of a well-behaved peer. So it'll be able to synchronize the entire chain through all the hard forks, mine blocks, and propagate pending transactions. The client will also be developer-friendly, supporting common dApp development like Truffle and Web3 and deployment use cases. This also means that the client will support JSON RPC APIs used by the popular clients, such as Net, Debug, Admin, but won't yet have technologies such as Whisper or Swarm, as we're focusing on core functionality, robustness, and modularity. We'll be providing more information and insight with where we're at in the coming weeks, and we're also planning on being more active in the community, such as providing feedback on the Ethereum reference tests.
Yeah, that's
This is Martin speaking.
great to
I'm
hear.
sorry,
Congratulations.
What language is it written in?
I'm sorry, I missed the question.
I'm wondering what programming language it's written in.
Pantheon is written in Java.
Okay, thanks.
Yeah, congratulations.
Yeah, congratulations.
Thank you. Thanks for listening.
Yeah, Sure thing. Cool. Do we have anyone from Nimbus or Mana or any other things? TurboGeth?
Hello, Alexis here. Yes, so I'm just currently testing one of the last things to test before the kind of alpha release is the reorgs. I just had to resync everything again, and it's now almost complete. And I already have a resync logic which I tested on my ETH tester, but just going to test it on the mainnet. And parallel to that, I started to doing some conceptual React architecture in the database, because I realized that even the database layout I'm using now is very suboptimal to what we actually need. And it turned, I mean, I've gone through some database research on this topic, and I found some data structures. I'm not going to go into the details here, but probably we'll do in a blog post later on. Yeah, so I'm getting close.
Great. Update from EWASM. You kind of gave one earlier, Axic, but if you have anything else to add.
Yeah, I don't think there's too much else. We still plan to release this testnet, but we don't have a final date on that yet. It hopefully is before DEF CON anyway.
There's also the EWASM token challenge, if anyone out there wants to write an EWASM token in the language of their choice.
Oh, that's true, Danny. Thanks for reminding. Yeah, we have a subset of a ERC20 token, a feature subset of an ERC20 token, which can be implemented in any language compiling to WASM. And there are already 4 implementations, one in C, one handwritten, one in assembly script, and a Rust version. So anybody is free to write in the language of choice, and we can test all of those and share the learnings.
Nice. Cool. Thanks for the update.
Hold on.
Yes.
Yeah, I'd like to mention in this channel that Hiat app, the old Python client based on Ethereum, is becoming officially deprecated very soon. Just so everyone knows.
I hope no one's using that. If you're out there on the internet and using that, stop it. There's better things. All right. So that's cool that it's getting. That's good that we're getting it officially deprecated. Thanks, Martin.
No, software I wrote is being deprecated. My psychological biases compel me to oppose this.
That's funny. Okay, so we'll get to research updates now. Oh yeah, go ahead, Peter.
Just a quick question: is there anyone from the Mist team here?
I didn't see anybody. I didn't see anyone from Ethereum JS either. Is there anyone from Mist here?
Anyway, so if not, just a tiny update. I'm not sure whether they told you guys about it or not yet. That they did a release a while ago, which basically when you start up Mist, it also enables, it basically connects to Infura when it starts up and then switches over to the full node when it finishes syncing. So that should be a really nice update for anyone using it.
That's
I'm
awesome.
not actually whether they told this on a core dev meeting or not, but if not, then here you go.
Oh yeah, they haven't mentioned it on a core dev meeting, but I did see they had a release like a week or two ago about that. It was like right after their last core dev meeting. So that's really cool.
Yeah, now we're actually getting bug reports that when people start up Mist, everything works, and they see their balances, and then when they start up Geth, they don't see the balance. So what the fuck? So it's really awesome.
Nice. Okay, so for research, Vitalik, do you want to lead it, or do you want Danny to start with, or Nate, or anyone else?
Well, Vlad, Nate, and I have been arguing about beacon chain fork choice rules a bit. Basically trying to, the place where we stopped as this is already getting into optimization territory, but trying to figure out what are the issues with, well, actually, sorry, just to kind of dial back a bit. About 2 weeks, Justin and I at Berlin started thinking about one issue, which is that, given that using, like, pretty much every random beacon scheme has its own flaws of different kinds. So what, like, for example, RANDAO has like more exploitability. Threshold VRFs have this like hard threshold online requirement, and VDFs have to worry about ASICs, like difficulty adjustment, and they have a high chance of being monopolized and all of those things. So we're basically trying to see, go back a bit and see, can we make the algorithm, like the beacon chain algorithm itself, more resistant to like a high level of manipulation of proposer selection. The basic argument here is that because the attester sets are very large, it's just basically statistically impractical to, like, even if you have perfect control over the random seed, it's statistically infeasible to really manipulate like even one attester set. But the number of proposers in one epoch is like 100, so that's totally manipulable. And like if you can perfectly manipulate the randomness. So the issue, the thing that we're trying to figure out is, can we modify the algorithm to be kind of much more robust against proposers being really unreliable? And the security assumption is that, like, worst case, imagine that within one epoch there's only like 1 or 2 proposers that are honest. And we think that we can, but it basically requires some fork choice rule modifications. So the problem with the old fork choice rule is that the old fork choice rule was very kind of proposer-centric in that it counted by heights, and proposers have this large power to basically prevent heights from incrementing or cause heights to increment. And the scheme that we're looking at basically one option that I'm thinking about is moving fully to something ghost-like, and one option is moving kind of partially to something partially in the ghost direction. The idea being basically that these if you have like chain A, and then on chain A proposers just stop showing up, then you have all of these dangling attestations. And can we make the dangling attestations still contribute to the keep contributing to the head score, so that even if you have missing proposers for a very long distance and then some other chain starts growing, that other chain still can't overtake the original unless it has more than 50%. And then at the same time also trying to like see how that fits into the finality gadget and the justification and kind of all of those details. So making progress, but still wants to kind of think a bit more, and also thinking about like making like the design space between sort of FFG style algorithms and CBC style algorithms, and like what the differences are and what the intermediate points are and so forth.
Cool. Any other research updates or comments? Oh yeah, we also have. Oh, go ahead.
I mentioned before the call, but we're going to do a sharding implementers call every other week. So that's going on.
Nice. Cool. Anyone else? So we also have some questions on the agenda. So basically, because EIP 1011, the hybrid Casper spec, is now deprecated, is there still interest to have a joint testnet, like a Ropsten successor, to kind of test some of this new stuff, maybe EWASM and other things? That's the first question. The other ones are, if there's an interest in this effort, how would it look like if there's not a hybrid Casper proposal, and what steps should we take to, in the meantime, while Casper and sharding is still being developed? So the first question is basically, what should we have a joint testnet?
Well, okay, let me ask a different question. Joint testnet for Casper?
Let me see, who made that comment?
I feel like if it's in the ultra short term, like a couple of months, then it should be a joint testnet just for WASM. If it's a longer term, like if it's longer term to the point where the beacon chain details are solidified, then a joint testnet for the beacon chain actually would be really cool.
Yeah, I think after if you want to give context to this question, that'd be great.
Yes, the context is that we kind of figured out that at some point it would be nice to have one big testnet for all clients again. And at this time, we decided this. We had this agenda to go forward with a hybrid Caspar approach. And then we started implementing this EIP 10.11. And I guess we were halfway through and started testing it. And then now we are at the point that we are deferring this or even closing this EIP. And I just curious if we should follow any further efforts to have another joint testnet that could be related at some point. So it's not really related to Caspar, my question. It's really just about the testnet effort.
Yeah. So if you ask me personally, I would say it would be really, really awesome to have a successor to Ropsten, particularly because Ropsten is probably getting way too heavy and it doesn't really make sense to keep it alive from my perspective. But feature-wise, as to what to put in it, I think EWASM would be a really nice addition because that's kind of fairly easy to add. Casper, now, my reluctance with Casper is that if we don't have a final spec and anything, so basically if Casper inside sharding, so the official Casper will be wildly different than the spec we have currently.
Yeah.
So I think that, like, first of all, we could distinguish between Casper and Casper with sharding, because like the beacon chain for the Casper with sharding thing can totally by itself be used as a single chain Casper setup. Yeah. So
I don't think you're suggesting using the Casper contract.
Right. No. I'm not suggesting using the Casper contract. Yeah, that's not something we're even pushing anymore.
Okay, so yeah, it sounds like there's not going to be a shared Casper testnet until we get much further down the line. Mm-hmm. So the successor to Ropsten would be EWASM.
But I guess my point is that maintaining a consensus engine is a ton of work because small quirks and whatnot. So it's completely fine to do it if it helps the final spec, but if it's just a temporary thing, then
yeah, and it sounds like it's more of a temporary thing. Cool. So what was the other questions on there? I think there was like... So it sounds like we are interested in an effort for a successor to Ropsten. It sounds like if we were to do that, we'd want kind of something like EWASM to be put in there. And I know that there's being an EWASM testnet developed right now. Is that basically exactly like the main chain, but with EWASM plugged in, or is it different?
That one currently has two quirks that bother me personally. One of the quirks is that they removed the code size limit, which is probably EWASM contracts require a bit larger code sizes, but that's a bit problematic point because, well, essentially that's also denial of service attack vector on the transaction pool. So it's we can't just allow arbitrary large transactions. So sorry?
Can I put a response in there? So it's not only the code size limit, but it's together with another change where we don't discount 0 bytes in transaction data anymore.
Yeah, that was the other one. I don't really understand why that would make any sense. So basically, network traffic is compressed and storage on disk is compressed, meaning that unless you have alternating 0101s, it should be able to compress it fairly well. So why did you guys decide to change the pricing rule?
I mean, the 0 bytes was also one of the attack vectors because it doesn't matter, it's compressed. I mean, that's an implementation detail, whether it's compressed or not. But you definitely can have an alternation of 0-1s or an alternation of anything and 0, which cannot be compressed anymore.
Right. Well, no, it still can be compressed because, like, if a 0 makes up 50% of the compression, like, in compression algorithm that's remotely close to optimal will assign 0 to, like, the 0 byte to be, like, less than 1 bit. So like, you should not be able to make something whose compressed value is, like, more than twice as long per gas than just random bytes.
Either way, so the exact changes are probably debatable, and it's probably not the right time currently to debate it. But the point I wanted to make really is that if you want to make a cross-client testnet, then I think it would be nice to somehow try to keep the changes to a minimum, because any kind of, so changes that don't really make sense or that don't really bring too much value, they always pose the risk that somehow they end up being enabled on mainnet. For example, the issue that that Parity had with Ropsten, that they accidentally leaked out an EIP there. So that's why I'm kind of afraid of all these tiny tweaks that don't necessarily bring value.
Yeah.
Okay. So it sounds like we still need more discussion and kind of hashing out of whether or not we're going to have another testnet successor that involves EWASM or not.
I think it's completely fine to have, just let's make sure that all the changes are actually needed.
Great. So yeah, what were you saying, Danny?
Oh, just, is it not worth having one that mirrors the current protocol so that we have a testnet ready to go, a joint testnet ready to go when we want to do the Constantinople fork? It's one that doesn't have any extra bells and whistles, but one that will fork into Constantinople before we do the fork of the main RAM.
Yeah, we can just keep Ropsten for that, or we can make a new one. It's
okay.
kind of up to what we want to do.
Current state of Ropsten.
Yeah, has Ropsten, does anyone know the current state of Ropsten, really? It's kind of been flaky lately.
Well, it's kind of like a stepchild, I guess. Parity's testnet is mostly Kovan, Gas testnet is mostly Rinkaby. So.
Yep.
What is the minimum level of sort of client support that we need for a testnet? Like with EWASM at this particular moment, we only have CPP Ethereum support. I'm not sure if that's enough for a testnet by itself, but we have like GET support, for example. Is that enough?
Well, I guess the point, I personally would at least like to see both Go Ethereum and Parity 2 agree on the spec, simply because if we introduce some really weird EIP or really weird protocol modification that is really hard to integrate in the other one, then we'll run the risk of not having the other client on board. So it would be nice to at least try to target the two majority clients at the same time.
So actually, I can, regarding the testnet plans on EWASM, we have a single VM in C++ which works directly with CPP Ethereum, and there's also work which is almost finished, to have it running with Go Ethereum, but it's still a single VM. And next to it, there is a separate chunk of work done to have a native Go interpreter for WASM. And I think that's also like, it's still in a prototype stage, but it's kind of working. One problem though with the testnet we are facing is CPP Ethereum doesn't support proof of authority. It only supports proof of work. So we have an option here whether we want to have both CPP and Go Ethereum on the testnet, and if we do, then they have to be proof of work, which is kind of suboptimal.
Well, yeah, but if you want a cross-client testnet, then proof of work is the only thing that all clients support. So even between Parity and Go Ethereum, both of us support a proof of authority, but it's different proof of authority. So if we want to do a proper cross-client testnet, then I guess proof of work is the only way.
And just reflecting to the earlier issue with the code size limit, that's of course up to discussion. And I think we're going to go with that setup for the pure EWASM testnet, but definitely when it is considered to have this other shared testnet, maybe even with WASM, then all of these things have to be reviewed.
Yeah, I guess my point is that, for example, our transaction pool currently, that transaction pool is limited to, so the transaction pool already filters out any transactions that is larger than, I don't know, 25K. And the reason is that because we kind of store about 6,000 transactions, multiply that by 25 kilobytes, and you have a nice few hundred megabyte memory usage just for the transaction pool itself. So if you just do a 10x increase on the code allowance, and you're already in the gigabytes. Worst case scenario is spam, of course.
Okay, we can take this offline, I think, as far as coming up with like kind of the details of the, if we were to do a cross client testnet, a new one that involves EWASM. But until then, we're going to have the pure EWASM testnet. Is there a timeline for that, Axic? You might have mentioned it earlier, I forgot.
Yeah, well, we definitely would like to have it before DEF CON.
Okay, sounds good. So next up, Alexei, can you talk to us about your idea for changing the network ID in Constantinople in order to make things backwards and compatible?
Yeah, so it's basically, I was looking at the networking code in Guest, and I noticed that there's multiple things, multiple places where we're still checking for this clean separation from the Ethereum Classic after the DAO hard fork. And in most of the places don't really matter, but the one it just kind of does matter is where after the handshake, every client is asking about the DAO hard fork block and the checks the extra data, and that allows you to essentially separate yourself from the Ethereum Classic, although they're still using the same network ID, the same handshake messages. So what I'm suggesting is that to change the network ID and actually have a practice of changing network ID every time we do hard fork, so that we always cleanly separate from the previous network. It does have some, so we will be able to remove most of the DAO specific code from a networking level but it does have you need to think about this thing, is that if we do change the network ID after the hard fork, then essentially we'll have to disconnect from all the peers and reform the network. So that's something to think about. Yeah.
Yeah, but there's another issue. Let's suppose that I'm a new node and I just joined. That means that whilst I'm syncing a chain, I need to serve the network IDs. And especially if I join currently, I will be on the frontier side of the chain. And then I need to already connect to Byzantium or Constantinople nodes.
So yeah, I haven't. I only just today I realized that there is this complexity about reconnecting, reforming the network. So I haven't really had a lot of time to think about it, but it would be nice to do that, because it would kind of make lots of things simpler, like preparing the hard forks.
So currently, the DEF peer-to-peer protocol supports extending the handshake with arbitrary fields. And Felix worked on that really hard for version 4 or something. What we can do is that we can extend the handshake so that it includes some arbitrary random data, and then peers will know whether they are on the same fork or not. And this would basically, we don't need to change the network ID, just add some extra metadata.
Okay, I think I'm just gonna need to think about it a bit more, but I encourage everybody else to also think about that, and because I think it would be really nice to just make a code much simpler there, and potentially have a cleaner forks.
Okay, thanks, Alexei. We're finally to Constantinople. So what I wanted to talk about today was, as much as we can, get certain EIPs to the accepted state. Even if they don't have every single thing defined, get them to where we're like agreeing to put them into Constantinople, and then start to talk about a timeline. So first off, let's just go through some of the EIPs and make sure we're kind of all in agreement that some of these are definitely going in. 145 bitwise shifting, we approved of that weeks ago, so that one's definitely going in. EIP 210 block hash refactoring is another one that I think we all agreed on as going in. I don't remember if we agreed on 1052 ext code hash or not. Does anyone remember?
This one, I think this one appeared quite recently, so I don't think we did. But it's one of those which is not. It should be quite straightforward, but we did not specifically agree on that.
Yeah, this is Nick's about returning the KEKAC 256 hash of a contract code.
We agreed on 1052 ext code hash.
Oh, Lane, were you asking a question?
No, that was Echo. I think.
Okay, no problem. So let's see. Where
I remember it being discussed as simple and useful.
Yeah, so we should put that in. Anyone disagree?
Actually, about simple and useful. So if you don't mind, I'm going to ask just a simple question about the EIP 210, right?
Mm-hmm.
I know that it's been proposed in the context of the Casper contract. Is it right?
This 210 is completely independent of the Casper contract. 210 is its own contract.
All right.
Cool. So 210, yeah, I'm pretty sure we agreed 210's going in. So 1052, straightforward. Everyone kind of wants it, so I think we should do it. So we'll say right now it's going in unless someone comes up with a reason not to. Net gas metering for S-Store. I think everyone's in favor of that. Christian might have had a comment or something. Yeah.
Sorry.
I wrote a comment on the Martin. I wrote a comment on the whole core dev channel. So what I don't, so the EIP says that the client implementation needs to maintain a dirty map of all the storage slots that have been touched during or modified during the current transaction and its sub-transactions. I don't think that's sufficient because there may be reverts in the call context. So the actual, at any point, you need to know which slots of those in the global map were touched by this call context and any child context that's
the one thing the one issue I see with this is that
I need to track the dirty and undo the dirty tracking in that. And I feel that there may be hidden complexity and quirks there. So I don't think it's quite as simple as the EIP says.
Yeah, no, I was about to say the same thing. Like, it's the main complexity that I see about this is that you don't have to just maintain a dirty map, but you also have to maintain a journal for the dirty map, and so there's risks involving, like, what happens if stuff gets reverted, what happens if there's, like, stuff gets reverted to different depths and then rewritten and so forth, and, like, we had to fight with these kinds of issues a huge amount 2 years ago, so I end up reintroducing a lot of trouble if we're not careful. The other problem is that this, like, it does it does definitely increase the complexity of a minimal implementation considerably.
Just to add a third problem to the issue, it does make blocks heavier. So essentially, if we reduce what this does is that it reduces the gas consumption of a lot of transactions, which is completely fine, but it means that it will be a lot heavier on the hardware.
Do we know how much heavier?
So I think I posted it somewhere, or I was asking somebody whether whether we could put a number on it, but maybe it would help to see that if we were to roll out this EIP on mainnet now, then what would that mean? How many more transactions could we fit in? How much processing time would those take?
Yeah. So in the worst case, like if we're assuming a DOS attacker, then this should not make things worse at all, because a DOS attacker would just make sure to fill in different fields, or make sure not to have a transaction that refills the same field anyway. With normal usage, yes, but I guess it would be good to have more metrics on like what actually is marginally contributing to the uncle rate, or like marginally contributing to load on clients the most right now, because it's like, to me it seems weird that blocks are being processed in a couple hundred milliseconds, but the uncle rate is still over 20%, and that like there are some cases where like if the block contents become closer to being pure simple transactions as we had in December, then the uncle rate went up to 40%, even though the gas consumption was the same. So like it would be nice to just try to do a bit of more detailed analysis and like see what actually is contributing the most, and like maybe it's not even at client level, maybe there's something weird happening at bandwidth level, and that would I feel like that sort of study will be necessary if we were to inform any any kind of short-term scalability improvements that we wanted to make?
One interesting experiment that we could do. So one hunch that I have is that block propagation is basically a significant component of the uncle rate. And one thing that we could try to do is basically just spin up 4 or 5 different virtual machines, different parts of the world, and just see how fast they get the blocks, because that might be an interesting data point to see whether there are significant delays between them or not.
Yep.
Peter, what do you mean by virtual machines?
No, I was just basically thinking that we should spin up 5 machines on Azure or on AWS.
I thought about this as well, and to make it actually much cheaper to do this experiment, I have a couple of days I've just created like a version of the guest, which is called the guest downloader. Essentially, what it does, it receives the blocks over the network. It does check the proof of work and so performance, but it does not execute transactions, and then it relays the blocks. Essentially, it downloads the blockchain, and this kind of stuff can sync in about a day or maybe like a day and a half, and it starts basically propagating a block around the network. So maybe, and then that would be quite cheap because you can run it on like a HDD. You don't have to have these expensive things. And so you can put lots of those instead of just running like a full node. That's the idea I had.
Yeah, I guess we could. So if we want to do such an experiment, we don't even need to retain the history. So we can just simply discard blocks. We don't even need.
No. I mean, like these downloaders are still kind of useful to the network because if somebody else joins the network, they will give them the blocks. So they will just hand over the blocks. So it's not like they're just kind of leeching out of the network, but they still have some useful function. I just didn't want to have like a complete leeches.
Well, yeah, okay. So I was talking about particularly this experiment. So yeah, if you want to have those that are running full time, 24/7, then yeah, you want to play nice.
Okay. So that brought up some questions with EIP 1087. So we'll skip that one for now and not say that's going to go in or not because we still have a lot of open questions. 1014 Skinny Create 2. Is there anything on that would be problematic to anybody or stuff that needs to be fleshed out? I think everyone was in favor of it too. Cool. No comments?
Was there any work to finish it up, or is it ready?
Is Skinny Create 2 ready?
I think so.
Yeah, actually, so Nick commented that it needs a discussion URL, but otherwise it's good.
So there was one question, I think, from Christian, right, listener, about the collision and like what happens when a collision. And I think my explanation was, which might not be right, is that if they create two will only create a contract if it does not exist already. So that
yes. Like, didn't we already flesh all of these edge cases out like 1 or 2 years ago? Because I remember we were discussing like in the yeah.
Yeah, in fact, the Go Ethereum code already has, the EVM already has a clause for this particular use case, even though.
And I remember well that there are test cases for the specific use case, so if people interpret it, like implement it wrong, then it'll get caught.
Cool. So it looks like Skinny Create 2 is going to be going in, so that's good. So the other thing is, do we want to delay the Ice Age whenever we do this hard fork?
When's the Ice Age?
Alex, do you have any more recent numbers about the next Ice Age?
Say that one more time?
Yeah, I was wondering if Vitalik has done the simulation again about when the Ice Age is going to be noticeable.
I haven't yet, but we can totally redo it. Although the other thing, actually no, there's a simpler way to do this. The Ice Age was delayed by 3 million blocks, correct?
Correct.
Okay, then
Yes.
all we can do is we can just look at the block time chart on Etherscan, which I'm going to do right now, and like in terms of block numbers, it'll be exactly the same. So if we pick the time at which the ice age kind of starts happening as when the block time reaches, say, 16 seconds, then that would be, let's see, June 5th, 2017. And I know that we have about 6,000, right now about 5,800 blocks a day. Actually, no, hold on. Do you remember what was the Dow the Byzantium hard for block? Was it 4.37 million?
It's a 4.37.
Yeah, okay, hold on. So 4.3, 4.2, 4.1, 4, 3.9, 3.8. So the time we have to worry is when the block number starts hitting the 6.7 million range. So that's when it'll like make the first spike up. That's like maybe less than a second up, but still noticeable. So 6.7.
It's actually going to be in a few months, right?
Hold on, let's check right now. 6.7 is still pretty far away. Right now we're at 5.9. So 6.7 is 800,000 from now. And 1 day is 6,000 blocks, so 100,000 blocks is about 17 days. Started about 6 months or so, yeah. And then after that, it'll take another 8 months or so until it becomes like really serious. So, and like delaying it in Constantinople like seems reasonable.
Cool. Okay. Anyone else have an opinion on delaying it or not?
I guess the question is what the timeline for Constantinople is.
We can talk about that before we decide on the Ice Age thing. So, yeah. Did anyone else have a comment before I move on to the timeline, and then we can go back to delaying it? Okay. So.
Wait, one second. Are we talking about timeline or delaying right now?
We're talking about timeline, and then we're going to go back to talking about delaying after.
Okay, perfect.
So, I put a proposed Constantinople timeline that's very, very optimistic. It's listed on the agenda, but basically, finalizing the EIPs according to the timeline should happen today. The client implementations happen for roughly a month between July 16th and August 13th. Testing would be August 13th to September 10th. The testnet would be September 10th to October 1st, and then we would launch October 8th. That would put us like 20 days before DevCon starts. I don't think this is necessarily reasonable, but I just wanted to put something down, and then we can start estimating how long it'll take for things. So Alexei had an alternative timeline that he posted as a comment. So I'll go down to that. And that puts us having a launch in January. Most people don't like working during the winter time because they're on like family vacations and stuff. So that's why I was wanting to get it done before DevCon, but I don't know if that's really feasible now, depending on which ones go in.
So my timeline is essentially based on the fact that we have to produce the conformance test for each EIP before most of the clients starts implementing it. So the idea was that we produce one reference implementation for each EIP, at least one, in any client, doesn't matter which one. Then that reference implementation allows you to generate some of the conformance tests, because you don't really want to calculate these hashes like the state roots by hand. So you just need some kind of implementation. So once you got conformance tests, then you can finalize the specification, because the conformance test might actually eliminate some of the problems. And so once you've got the conformance test and full spec, then you go ahead and implement it everywhere, and that should be much more straightforward than now. This is what my timeline was based on.
Isn't that already how we have done it previously? Except that the reference client implementation has always been CDP Ethereum, since that one has been used to make the tests.
Yeah, maybe. I mean, I'm not saying that it hasn't been done like this, but it's I just wanted to be kind of formalizing the timeline, because at the moment it's kind of smeared around the different stages.
Well, I guess up until now, implementing the stuff and creating the tests for it was kind of concurrent thing, which isn't necessarily a good thing or a bad thing. It was just the way it happened.
Well, I'm just conscious that the situation changes over time. So in the beginning, the client implementers probably had more time to do this stuff, but now everybody is busy fighting their own fires, and they really need to kind of a proper full spec with the with a very little chance of it being unimplementable before they seriously start doing it. And I think we should get to that stage.
So I think that that's similar to how we've done it in the past, except we've done things concurrently, like Martin mentioned. So, like, we're implementing it in clients while we're creating the test, at the same time having C++ be the first implementation that everyone copies from, is kind of how I understood it. So that's similar to what you put down, Alexei, and I like that you did it the way you did, because my timeline that I put down was kind of waterfall method, where it's like one after the other, whereas really it's more agile the way we're doing it, where it's kind of things happening concurrently.
And then it could still be my timeline could still be concurrent if you look at this kind of timeline can go for each EIP separately. So you don't have to do it first for the first EIP, then for the second. You can actually concurrently make reference implementations for all of the EIPs at once, and then produce the test for all of them at once, and then you converge somewhere. And along the way, you might say that, oh, we're going to keep that one out because it's too much, and then just arrive at the fewer EIPs.
Okay. So, go ahead.
Could we set a priority list for those EIPs and maybe reevaluate according to those timelines where we stand with those? So maybe we select 5 of these EIPs right now, but we say, for example, bitwise shifting is priority 1, block hash is priority 2, Xcode hash is 3, etc. And we reevaluate as we go which one is done.
So from my personal perspective, I think bitwise shifting, Xcode hash, and skinny create are trivial. So I don't really see why those would pose a problem. Net gas metering could have surprises. Block hash, I'm not that familiar with it. So.
Yeah, I think this is different than previous hard forks where we had more very, very high profile, high risk changes. I think it feels like, at least.
Yeah. And 210 is kind of entering fundamentally new territory because it's the first kind of privileged EVM contract that gets called as part of block processing. But even that is it's a significant change on the surface level. It's not a deep change to how the EVM works.
I totally agree. However, it's not, as far as I understand, it's still not finalized, the actual leak. There's still some changes that needs to be done to it.
For which one, 210?
Yes, 210.
I thought it was finalized, or not finalized technically by EIP standards, but I thought that it was written out completely. I might be wrong.
Now that it's not been changed recently, we decided a couple of quarter calls ago to add Genesis information.
Oh, yeah. Okay, so Vitalik just needs to go in and add that then.
Right.
Yes.
Well, another question I had about the 210, which we probably already answered somewhere else, but are we writing the smart contracts in basically EVM bytecode, or are we writing it in the high-level language? And how are we going to verify
is it the intention that this
whatever
is? Hold on, let me check. I know that I published I think I published the EVM and the LLL for it. I feel like LLL is kind of the appropriate level to write it because it doesn't introduce high-level compile, very complex compiler risk, but it's also readable.
And you think you published that somewhere?
Yeah. I'll check.
I think you published the Viper and the bytecode.
Serpent, just Serpent and bytecode, and I could just create the LL for it then.
Yeah, if you can do that, that would help us, I guess, understand if it's going to be a little bit more difficult to implement. Okay.
So at the moment, it's Serpent language.
Right. Okay. Like it's the type of Serpent that seems trivial to convert to LLL.
Don't really care about what's in the contract.
Well, what the reason I'm asking is because basically we need somehow the audit to so kind of audit or this kind of contract or whatever the bytecode is, or have we done it already?
So Paul, what were you saying?
Yeah, so the current code is in Serpent, I think, and I also reported some issues with it, and they are in form of pull requests and pending for a long time. And it's kind of hard for me to actually move on with this one because every time I propose some change, it like waits forever, and I cannot I'm not able to queue them up easily. And I don't want to like move all of the issues at one point because then like I will never get any review. So I think there are one or two pull requests that have two in the title, and also we were thinking about using a bit lower level implementation. Either can be allow or maybe some kind of Solidity assembly, something that is quite close to the EVM opcodes.
By the way, do we have test cases for this?
For 210?
Yeah, for the code, yeah.
That's a Dimitri question, unless someone here knows.
No, I remember didn't like Martin test.
I have written some unit tests for it, but I think in the end, I don't remember. There was some suggestions not to include that in the EIP or have it somewhere else. But there should be a pull request that contains them.
Yeah, but there's a funny quirk with how it works right now, which makes it won't work in Hive cross-client testing, because if you try to enable it at block 0, then it will wind up in a recursive loop storing the block hash. So that's one of the issues that Paul is discussing that's currently hindering it from actually being used in cross-client testing, I would say.
Okay. So 145 is pretty clear cut. So is 1014 for Skinny Create 2. So is 1052 for ext code hash, I think. And then block hash refactoring needs some work, and we need to discuss 1087 more. I think.
And one more, we haven't talked about it this time, but I recall that Vitalik earlier has been a proponent for lowering the gas costs for some of the new precompiles. Is that still something you want with Constantinople, Vitalik?
Oh, right. You mean the lowering it for up to curve stuff?
Yes.
I think so, but like I guess I would like to see like other so first of all, is it just Geth that added optimized libraries for it, or did Parity like improve their libraries as well? And like what about other implementations?
Well, if any of you have some Solidity benchmarks or Solidity code that I can benchmark with, it's really trivial to inject them into Hive and just run it against all the clients.
Well, when we were adding the EC precompose for Byzantium for the first time, we did do the analysis, right? And we set the 40,000 like in the 80,000 in gas costs and so forth because we wanted to target like 20 million gas a second, right? So like there were measurements that we clearly did, and you can just redo them with the new with whatever new software the clients have.
Yeah, it's not as trivial as that because there were relative benchmarks too. So on one machine, you did relative benchmarks between the new precompiles and the old precompiles, and we didn't. Yeah, and they weren't the same benchmarks that we run on Geth as we run on Parity, because we had implemented different type of test harnesses. So yeah, we can redo it, but and I plan to do it, and I'm wondering how much effort to put into that, based on how much you want it into Constantinople, basically, how much we want to change it to Constantinople. But what Peter is saying is that if he doing it the way Peter suggested makes it easier to automate and just hit the button and do it for all clients that are Hive compatible.
Oh, Lane, could you mute?
Sure. You getting background noise here?
A little bit.
Yeah.
But I will try to redo the benchmarking, and I need some help from the Parity guys and the CPP. I think Powell did a lot of the CPP measurements last time.
Okay, so that's something you can do once things are more clear, you're saying?
They don't have to be more clear. No, I can do it. I just wanted to know how badly we want it.
So for example, ZK snarks are part of the Hive benchmarks. I added those 4 months ago, but those aren't really, so those are kind of a complex interaction. It's really hard to measure the individual weight of certain operations.
Okay, any other comments? So judging by how we have, how we haven't really gotten exactly which EIPs are going in yet, and the timeline's getting closer and closer to DevCon, it's probably going to be post-DevCon before this is released, unless we start moving here. So if that's the case, we probably should delay the Ice Age, in my opinion, because by then we'll start seeing some effects in 2019, from what you were saying, right?
Right.
For the Ice Age?
Mm-hmm.
Okay.
Yeah.
So, and at the earliest, we're going to get done in late 2018, early 2019. This hard fork is what it's looking like. Does anyone want to really push the agenda and make it earlier than DevCon?
Hudson, I had put something on a comment to the GitHub issue that perhaps it's worth thinking about not bundling everything in Constantinople, but simply releasing changes as they are ready. Let's say that if we know that the shifts are pretty straightforward and they pretty much ready, why don't we just do hard fork with the shifts? I mean, what is the biggest problem with that?
No, there's a huge
coordination problem.
So
where's it coming from?
You have to ensure that everybody updated. You have to test the whole thing. You have to roll out on the testnet exchanges, whatnot. Everybody will.
Like, if we want to guarantee a hard fork before DevCon, then like I'd recommend like probably kicking out 210, just because like kicking out 210 and kicking out 1087. Probably, so you have bitwise shifts and skinny create to an ext code hash, because those all seem fairly simple.
Yeah. So this can kind of be like a little hard fork if we want.
Yeah.
What's everyone's thoughts on that? Does anyone think that it's worth, and it's crappy that Nick's not here to defend his case for the net gas metering for S-Store, but I think it was just proposed a little bit too late in the game, is what it's looking like, because there's a lot of open questions about it.
Well, to be honest, this is why we originally suggested that everyone who proposes a fork or EIP should at least have a reference implementation, because then it's easy to argue about. So maybe an easy step would be, luckily Nick isn't here, would be to get Nick to actually implement a reference and submit a PR.
Okay. Yeah, that might be a good future requirement. Yeah.
So for me, I'm for at least moving 2.1.0 at the end of the queue of EIPs, because seems to be quite complex anyway, and I don't see a lot of pressure to actually implement that. I mean, I haven't seen a lot of use cases that really would like to have it.
The main use, I think the main practical use case is like one enabling light clients that can sync without like literally processing every block header, and yeah, the other, which is like potentially useful, right? Like it would be nice to have a light client that can sync trustlessly in logarithmic time. Though, like if you want to actually achieve that in practice, it requires not just the EIP, it requires all of the other code. So like it may well be the case that actually achieving it is not worth it, and we can just rely on the existing approach until we get to like some like proof of stake for like client functionality or whatnot. I don't know.
Well, the other alternative would be not to go with the contract-based approach and simply add another opcode or something. That would be much easier to implement.
Well, not an opcode, but like I guess a non-contract based.
Sorry, this is muted.
Like basically to take the code that was written there in Serpent and just implement it in whatever is the code of your whatever the language is that the client was written in.
No, just simply have the whatever block hash now can only go back 257, whatever, 57 blocks. But just do the block hash 2, which can go back whatever down to 0.
No, that's dangerous because it makes it could make life a lot harder for light clients, and it basically means that like the entire historical set of blockchains becomes like technically part of the state, and like it nullifies the benefits of kind of automatically having blocks get hash linked to blocks that are much older than they are. Like, yeah, like I see the primary benefit of this EIP kind of precisely being that you have a storage tree that contains like some subset of previous block hashes.
So I really want to have it finalized as long as the spec is considered. I just like feel it's less mature that the other three we almost have ready, and that's the only issue. And still I blame mostly myself not finishing this one.
You're good.
Yeah.
I would say that I think I agree with you that 145, 1052, and 1014 should be priority, because seem to be the easiest to implement. And what we can do is we can start making tests and start implementing those three, and then throughout the next core dev meeting we can decide on the other two and talk more about them. I think that would be valuable. Mm-hmm. And also it would help us to move forward, because right now we've kind of been at a standstill for months about what to do with Constantinople, so I'd like to move something forward.
Agree.
Personally.
Right. And there's the option of doing Constantinople soon with these and not changing the Ice Age, and then doing another fork early in the year and changing the Ice Age. Just a thought.
Yeah, that would apply some pressure, definitely.
So I think we need a bit more precision in this. So firstly, the state test for shifts are ready, and you can already start testing them. You just have to enable Constantinople hard fork in JSON test, whatever. But they are ready in the tests repo. And second thing is, I think what Dimitri explained, it's much easier to decide on the order. So we can add another EIP to this virtual Constantinople hard fork configuration in tests. And so we just need to pick one of the two left. because that's much easier to coordinate this way instead of trying to dump the test for all EIPs at once.
Are you saying create the test iteratively or make an EIP that defines which ones are going into Constantinople?
Just specify which EIP will go next in terms of generating tests for it.
Okay.
To be
And you're not
published
saying
in the tests repo.
and
It
you're
can
not
be
saying
both at the same time, but it would be probably much better if we just decide which one goes next. I guess like because we had this create to implementation in some places, and maybe we had some test for that, the skinny create to might be the best candidate for it.
Yes, I completely agree. Yeah, because if you have reference implementation, it's super easy to make the test.
So I would pick the like after shifts, which are already there. Maybe there's like not the full set of tests yet, but some of them are there. I would pick the skinny create 2, and yeah, I think we can focus in CPP Ethereum to finalize the implementation of it and start generating tests next week.
Great. Peter?
Yeah, I think I can agree with that suggestion that basically we have the 3 easy PRs. Those should be easy enough to implement, and then we can also start writing tests for it. And then maybe while people implement these 3 and write the tests and see whether it works, we can actually ask Nick to maybe write up a proof of concept or to debate it for maybe next quarter meeting in 2 weeks to see what it would take approximately to do that. And then based on that, we could have a good starting point on whether we want to test that or whether we don't want to test that.
Sounds good to me. Anybody have any other comments on this? Cool. This sounds good. We have shifted towards, or not shifted towards, we're coming together to say that 145, 1052, and 1014 are low enough hanging fruit, and they've already either been started that we can go ahead with them.
If people want a version of 210 that's much simpler and doesn't include like EVM dependencies, I just did an extremely quick write-up. If you look at number 1218, it gives like at least half of what I think we want, but it's much simpler.
Here, I'll post it into the channel.
Can it be turned into the bull without much issue? Like, is it a stepwise thing?
Can it be turned into what?
Can it be turned into the full 210 over time in another fork, or is it
probably
completely different?
But like the fundamental form is kind of the same, though it does kind of handle some other things in a way that's somewhat different.
Okay, so we can look at that and discuss it for next meeting, I'd say. Sound good?
Sure.
Cool. Okay, so I think we have some good conclusions from this meeting. Do other people have comments on this? And we don't have a timeline exactly, but what we do have is we're starting stuff, and depending on how fast we get stuff done in the next 2 weeks, we can actually start to set some dates and finalize some things.
Sounds good.
Could we make a declaration? Are we aiming for before DevCon?
I think we should aim before DevCon, but that's not final yet because I feel like we have not reached consensus on that.
Yeah.
I think if we do reach consensus, like if people say we want this done before DevCon, I think we have to only do these 3 EIPs. I don't think we can do more than that. But that's just my opinion.
When is DevCon?
October
1st, something like that.
It's like October 30th to November 3rd or something.
Oh, come on, we can do at least 4 EIPs until then.
I like your enthusiasm, and if you're being serious, then yeah, we can do 4.
Let's do it.
Okay, so let's see if Nick can implement his S-store stuff, and we can get an idea of any pitfalls that we'd run into. Peter, can you talk to Nick and ask him to do that? If not, I can message him.
Yeah, sure.
Cool, thank you. Just explain what we talked about in the core dev call. All right, anyone have anything else? Otherwise, I think we're about to wrap up. All right, cool. Talk to everybody in 2 weeks. Lane or myself will have notes up, and I can put in the core dev channel what the next to-dos are. Bye, everybody.
Thank you. Bye-bye.
Thank you. Bye-bye.